Okay, these are notes 8.1 for geometry. I'm just going to warn you, they're probably going to be long. Some things you need to do are to number one, have your compass available. You need a straight edge, so like your badge, your student badge, or a ruler. Um, then number three, you're going to need some extra paper because there's not a lot of room on these notes, and I'll do it this way, actually spell the word. And then number four, you need to be able to think. Okay, don't just take these notes passively. Think about what you're doing. Okay, because it's important, and you want to make sure you're understanding what I'm saying. Okay, so let's jump in. First of all, let's talk about the difference between a ratio, which is a comparison of quantities. It could be two or more quantities. A proportion, on the other hand, is a statement that two ratios are equal. So we could say, this would be an example, A over B is equal to C over D. Okay, and the terminology, just for some vocab, if we were to write that out, it would be A is to B as C is to D. And in mathematical terms, we would call A and D the extremes, because they're the ones on the outside. They're the extremes, and the two on the inside are the means. So that's just a little bit of vocab for you. Now, let's do a couple of these examples. The ratio of the side lengths of a quadrilateral are 2 to 3 to 5 to 7, and the perimeter is 85. What is the length of each side? So since we don't know exactly what they are, we have to use x as our common ratio. So we're going to take each one of these sides and we're going to say 2x plus 3x plus 5x plus 7x equals 85. So you get 17x equals 85, divide by 17, x equals 5. Once you know what x is, your common factor there, plug it into 2 times 5, 3 times 5, 5 times 5, 7 times 5, and you find out the sides of this quadrilateral are 10 feet, 15 feet, 25 feet, and 35 feet. Okay? Next question. This is where you might need a little extra paper because there's not a lot of room here to solve this problem. It says solve this. Now we have a proportion, and the way we solve proportions is by using cross products. And what do I mean by cross products? When we have A is to B is equal to C is to D, to solve it we can do A times D is equal to B times C, and then solve. So on this one, we're going to take 2x minus 4 right here times x minus 3. That's one side, and then the other side is going to be equal to 8 times 5. Now, you're going to do double distribution here, so you get 2x squared minus 6x minus 4x plus 12 equals 40. So we end up with 2x squared minus 10x, and then I'm going to subtract 40 from the 12 and get minus 28 equals 0. Now we have a quadratic equation. Two ways you can solve it. One would be to factor it. And remember how we factored? Remember, a quadratic is ax squared plus bx plus c in this format, and so we take a times c. In this case, it would be 2 times negative 28 is negative 56. That's your product. Then you take b, your middle term, that's your sum, negative 10. Then we find two numbers in here that multiply together to give you negative 56 and add together to give you negative 10. And if you're having trouble finding those, go to y equals in your calculator, type in negative 56 divided by x, and then go to the table and then just look down at all the numbers until you find two that add up to negative 10. In this case, it's going to be negative 14 and positive 4. And so then you take your quadratic, 2x squared minus 10x minus 28, and we split up the middle term is going to be minus 14x plus 4x. That's where we got this from, right here. So bring the 2x squared down, the minus 28 down, you group, and then find the greatest common factor. So in this first group, the greatest common factor is 2x, so you're left with x minus 7. And then on the second one, our greatest common factor is 4, and you're left with x minus 7. This is always going to happen when you're factoring. You'll have two that look alike. Your two factors now are what's outside the parentheses and what's inside the parentheses. Then to actually solve, we are going to do the following. And I wrote something wrong on there. It was 2x plus 4, not 2x plus 7. So let me fix that. What's outside the parentheses was 2x plus 4. So we're going to take 2x plus 4 equals 0 and x minus 7 equals 0. Split them up, set them equal to 0, solve for x. So on this one, x equals negative 2. On this one, x equals positive 7, because we subtracted 4 and then divided by 2 over here. So there's your two solutions. So negative 2 and 7 is what our solutions are. Now the other way you could solve that, and sorry, I made that picture disappear. Take your quadratic, 2x squared minus 10x minus 28. Put that into y1 in your calculator, and then on y2 put 0. Graph your quadratic and find your solutions using second trace 5 for intersection, and find the intersection over here, and then go through that process again and find the intersection over on that side. You're still going to get 2 and 7. Okay, so now let's look at number 3. This is given that 18c is equal to 24d. Find the ratio of d to c. So when we say the ratio of d to c, we're going to write it like this, d to c. And so let's write this down. 18c is equal to 24d. Now I want to get to the answer. What is it when it's d to c? So I'm going to divide both sides by c. So we have 18 is equal to 24d over c. Now, how am I going to solve for d over c? We're going to divide both sides by 24. So I have 18 over 24 is equal to d over c. Now it said put it in simplest form, and these are both divisible by 6. So that's going to be 3 over 4 is equal to d over c. And you can see that if we were to do our cross products, 3 times c is going to be equal to 4 times d. And if we we're working backwards from what we did to solve this. If I multiplied both by 6, now I'm back to what we started with. 18c is equal to 24d. Okay, so that's how we would solve for d to c. So d to c, d is to c as 3 is to 4. Okay? Now we're getting into the little tricky part. Got to have your compass, got to have your thinking caps on, and this part about the golden ratio is a very key concept in all of mathematics, and in fact in the way our universe is created. All follows this rule. Now, first of all, I want to just mention that probably with copying and everything that's happened over the years, there's no telling if this is really a 2-inch square on your paper. So we're going to use our compass for measuring, not a ruler. So we're just going to assume it's 2 inches long. So the first thing we're going to do, it says use the square And it says find the midpoint, number one, find the midpoint of this square using construction. So remember, to use construction, we can take our compass and put it on this point, this vertex right here. Set it a little bit wider than what you believe halfway to be is, and swing an arc. And I would do this very lightly. And then same thing over here. Go over to this side without having changed your compass, do another arc, and then this intersection right here is going to be your midpoint. So use your compass to do that. And once you have your midpoint, then it says connect, and label that M. So we're going to label that M. And it says connect it. So we connect this. And now we know this is right angle right here since it's a square. And it says use the Pythagorean theorem to find the length of MC. So we're trying to find this hypotenuse right here. So let's use the Pythagorean theorem. We're going to do a squared plus b squared equals c squared. So 2 squared, and if this is the midpoint, we know this is 1 and this is 1, so this is plus 1 squared equals c squared. So 4 plus 1 equals c squared, and we find out that c is the square root of 5. So MC equals square root of 5. Okay, now this is where things are going to get a little tricky. And I probably did you wrong by doing all that math right here, because we're going to use this space to do some construction. So we have our square. It says extend, for number 3, extend AB past B. So you're going to need your straight edge and line it up with AB and then draw it out this way. Now, here I'll put my information here. It says label that, okay, let's see, with a compass point open to the length of MC. So we're going to put our compass at that midpoint and we're going to measure it to C. And keeping it right there on that midpoint, you're going to draw an arc. And hang on. When you do that, it's going to go like this and come around like that. Now, granted, I can't do it very well on this iPad, but I did all of this with my compass, and you'll see what happens. So we get that intersection right there. We're going to label it point E. That's what it says to do. Now, and since we know that AM is 1, we know that this distance right here is the square root of 5. Then we know, since we used our compass, which was this distance right here, and we used it to find this point here, we know that ME is how long? ME is also the square root of 5, because it's from here to here. We used our compass to measure that. Okay? So now, knowing that, since AM is 1 and ME is the square root of 5, then the length of AE, this whole thing here, is 1 plus the square root of 5. We'll put that in parentheses, inches. Now, how long is segment BE from here to here? Well, let's think about that. We know that from here to here is the square root of 5, and we know that this is 1, so we can say this is the square root of 5 minus 1 inches. So far, so good? Now, it says construct EF 2 inches long and perpendicular to AE at E. So, okay, the next thing, number 6, and it's a little bit off my page, but I don't want to move the picture away. It says construct EF 2 inches long and perpendicular to AE. So here is AE right here. So we want to do a line that's perpendicular. So we're going to do a line right here perpendicular to AE. Now, in the interest of time, I'm going to allow you to just use your straight edge. Make sure you have it squared up, and you're going to draw a line right here. And of course, I'm having a hard time doing it on my iPad straight. But it needs to be perpendicular, and then it says, the next thing says extend CD to this point, and so we're going to label that point F, and it says now on number 8, compare the ratio of AE to AC and FE to EB. So this is where things will be a little bit tricky. So AE, that's from here to here. And we know that AE, we already found the length was 1 plus the square root of 5. So we're comparing AE to AC, which you'll notice AC is the width and AE is the length. I'll write that in a different color. So the length to the width, 1 plus the square root of 5, and AC is how long? It's 2 inches. So pop that baby in your calculator, making sure you use parentheses. 1 plus the square root of 5, close your parentheses, divided by 2. And you will find out that it is approximately equal to 1.618. It's not going to be a rational number. It's going to go on and on forever, but we are going to round it to 1.618. Now it says compare the length of FE to EB. So here's FE, and we know it's 2 inches, right? And then to EB, that's this part right here. So we already found the length of EB earlier in our little activity, so we're going to do FE to EB, and in this case, instead of being, again, it's going to be the length. FE is the length on this rectangle, and EB is the width right here. So we have FE is 2, and we're going to divide it by the square root of 5 minus 1 in parentheses. Put that in your calculator, divide it, and you find out the ratio is 1.618 again. So you can see that this smaller triangle is similar to this larger triangle. We have this large triangle here, and it's similar to this triangle here. Now, guys, that's what we call the golden ratio, because we could do this all day long. We could construct another square right here. And then one like this, and one like this, and all these squares and all these rectangles would all have similar ratios. If we did the length to the width, they're always going to come out 1.618 every time. Okay, now let's turn to the back. Okay, part 2. What distinguishes the golden rectangle from other rectangles is the ratio of the length to the width. I just mentioned that. The rectangle shown is a golden rectangle. Its length is 1 and its width is x. A square with a side length equal to the width of the rectangle is drawn inside the rectangle. The remainder of the original rectangle is a rectangle that is similar, so that the ratios of the corresponding sides are proportional. Okay, that's basically what I was just saying to you, that we can keep drawing these squares and rectangles so that their sides are proportional, although I didn't do that one very well. Like this, etc. But now let's look at the proportion. it says, use the segment addition postulate, part plus part equals whole, to write an equation relating x and y. So here's x, here's y. Sorry, just got a little bit interrupted there. X plus y, there's x plus y, and that equals 1. So we're going to write that x plus y equals 1. Now it says solve this equation for y. So we're going to subtract x, and we get y equals negative x. Well, let's not do it that way. Let's go like this. Y equals x minus 1. Okay? Now, it says the larger rectangle is similar to the smaller rectangle. So we have this ratio, 1 is to x as x is to y. You can see that over here. Length is to width, 1 is to x as, remember, here's this one, length is to width as x is to y. So these are just length to width ratios. Okay, 1 is to x as x is to y. Now it says substitute for y in the proportion so that it is in terms of x only. So here's what they're saying. Take this ratio, 1 is to x as x is to, and since we know that in this proportion y is equal to x minus 1, we're going to put x minus 1 right there on the bottom. Now we're going to do cross products. We're going to cross multiply. So we get x squared right there. Actually, I did it the other way earlier, so, but I think I'm just going to start this way. X squared, and then is equal to 1 times x minus 1 equals x minus 1, like that. Okay, so we did our cross products. Now, it says put all the terms in the equation on the left side. We want to set it equal to 0, kind of what I did earlier. So we have x squared. We're going to subtract x, and we're going to add 1. So we have minus x plus 1. Did I do that right? Oh. Okay, you got to shoot me in the head again. Lord have mercy. Okay, look up here. When I subtracted x, I said 1 minus x. It's 1 minus x, not x minus 1. 1 minus x. Oh, sorry. So this is 1 minus x all along here. 1 minus x. This is 1 minus x. And so now I need to add x and subtract 1. Sorry about that. So x squared plus x minus 1. You got me on that? I'm really sorry about that. We had x plus y equals 1. We subtract x. That means y is equal to 1 minus x, not x minus 1. So, blah. Sorry. Okay, now, it's everybody's favorite thing. We're going to use the quadratic formula. Okay, do you remember this from last year? The quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In case you forgot how to write it, that'll help you remember. Sing a song. So now we want to find solutions to this. So when we're using the quadratic formula, we have to know what a equals, we have to know what b equals, and we have to know what c equals. So look at our quadratic up here. A is the coefficient of x squared. And what's in front of that x squared that we don't see? A number 1. What's the coefficient of b? It is also 1, and c is negative 1. So now we're going to use our quadratic formula. X equals negative b. So we're going to take b and make it negative. So negative 1 plus or minus the square root of b squared, which is going to be 1 squared, minus 4 times a times c all over 2a. So let's keep working this out. We get negative 1 plus or minus the square root of 5 all over 2. And Now remember, to get your solutions, your final solutions, you would take -1 plus the square root of 5 over 2 and -1 minus the square root of 5 over 2. So you can tell from these first two solutions, from these only two solutions, that this one's going to end up being positive because we take the -1 and we're adding the square root of 5. Square root of 5 is a little bit over 2, so we know it's going to end up positive. This one, on the other hand, is going to end up negative. And we don't need the negative solution because we're talking about the length and width of something that's real. So we're not going to use the negative solution, we're going to use the positive one. Okay, so keeping that in mind, we're going to use the positive solution, so I'm going to ditch this one right here. And let's put that in our calculator. And when you put that in your calculator, -1, put it all in parentheses, -1 plus the square root of 5, and then divide it by 2. And what do you get? You get that it is approximately 0.618. Now, I would like you to find the reciprocal of that. What does it mean to find the reciprocal? It means to take your fraction and flip it. So take 2 and divide it by -1 plus the square root of 5. And when you do that, you find out that the reciprocal is our golden ratio, 1.618. Now, I want you to see, and I'm going to draw this down here. You might want to draw it somewhere else on another piece of paper. But here's our original square that we had up above. And these were each 1. And, or if I could say they are 1, we would say that this length right here is 1.618. And this small length right here is 0.618. So we've got this length, 1.618, is to the width, length to width, as on this one, length to width would be 1 over 0.618. And you will find that if you put this in your calculator and you put this in your calculator, they're going to come out exactly the same. Exactly the same. These two ratios are the same. So when you're working problems, you could use either one, but I would say for our purposes, we are generally going to do it this way. Take the length and divide it by the width, long to, and you'll see what I mean. Length to width, 1.618 over 1. So let's look at these problems, example 4 and 5 that we have down here. Okay, it says, below is a golden rectangle. Find the dimension of the rectangle ABCD. Okay, so we know that if it's a golden rectangle, the dimensions are going to be 1.618 to 1, length to width. And so our length on this one is right here, is 4 to what? X is what we don't know. And then we're going to use cross products. Cross multiply, and we get 1.618x is equal to 4. And we're going to divide each side by 1.618. And you get that x is approximately 2.472. And so your dimensions of this rectangle would be 4 by 2.472. Okay, let's try the next one. A golden rectangle has a side measuring 7 centimeters. Find all possible lengths of an adjacent side. So we don't know whether this is the length or the width, so we can draw this two ways. We could say we have from here to here is 7, and this is x, right? Or we could go like this, and we could say from here to here is x, and this is 7. So let's do it both ways. So remember, our ratio is length to width is 1.618 is to 1, and in this case we're going to go length to width is going to be 7 to x. This is on the, I'm doing this one here, first one. Okay, do your cross products. 1.618x equals 7, divide, and you get x is approximately 4.326. If I was going to round that just to the nearest tenth, we would say 4.3. Okay, now let's do the other one. We have length to width. So our length, let's always put our ratio first. 1.618 is to 1, as, in this case, x is to 7. And now we're going to cross products, and we're going to take 7 times 1.618 and equals x. And when you multiply that, you get approximately 11.326, which would be approximately 11.3. So there's your two. Now, before you go, we're going to do a few more. Oh, golly gee Moses, I didn't know the thing was still running. I want you to put all these down. I want you to solve for x on all these problems. Okay, so sorry about that. Let's see here. This one's going to be 30 up here. X right there. This one will be 24. X. And this one's going to be 10. X. So, you have these 6 problems. Figure out your ratios. Let's round 2 decimal places. Okay, 2 decimal places, and have those done when you come to class tomorrow. Okay, so we'll see you then. Good luck, and there's your lesson.